Okay, good morning, Year 12. Welcome to what was meant to be Mr. Smith's 5-minute, not very technical guide to the chain rule for differentiation. We had a few technical issues, so Mr. Smith sent me a few photos of what he was going to do. I won't use this horrible grey sheet for most of it though. Right, so chain rule is generally for more complicated functions. So generally, if you have a function to the power of n, it'll differentiate to n lots of the function to the power of n minus 1. So that's similar to what it was before with normal differentiation, but then you have to also multiply by the differential of the function. So for example, if we did 3x add 2 to the power of 9, it's meant to be a 9. So if you differentiate that, so following this rule, you multiply by the power and lower the power by 1. But you have to remember to multiply by the differential of the function. So we're going to multiply by the differential of this, which will be 3. So altogether, you would have 9 times 3 is 27, 3x add 2 to the 8. If we go for 5x minus 1 to the 7, if we differentiate that, then multiply by the power and lower the power by 1, like you would do before. But you've got to then multiply by the differential of this, which is 5. So 35, 5x minus 1 to the 6. Right, third question. 3x squared minus 2 to the 9. So following what we did before, times by the power and lower the power by 1. But this time, when you multiply by the differential of the function, you've got something a tiny bit more complicated, 6x. So you are left with 54x to the 5 times by 3x squared minus 2 to the power of 8. Just keep building up these functions, make them a little bit more complicated. So if you have a negative fractional power, it still follows the same method. So multiply by the power and lower the power by 1. Really easy mistake to make there is to mess up, going from minus 3 over 2 to minus 5 over 2, so be careful. But then you've got to multiply by the differential of this. That differentiates to 8x. Minus 3 over 2 times 8 is negative 12x. 4x squared minus 1 to the minus 5 over 2. Right. So this next question is almost the same. It just looks slightly different. So if you have 5 over root of x squared, 8x squared minus 1, first thing you need to really do is you need to turn that into a more manageable form. So you should remember that that is 5. Then if you have a square root, it would be to the power of a half. So it's this bottom bit to the power of a half. But then if it's on the denominator of this fraction, it will be negative a half. So at this point, I've said that this is equal to this because it is. I've not done any differentiation. Just to be like I was doing before, partially for laziness. When I've differentiated, I've put an arrow. I haven't put equals because it is not equal. So back in this question, that was not equal to that. I'm just saying this differentiates to that. So Then if we differentiate this, if you multiply by the power, so minus a half times by 5, 8x squared minus 1 to the minus 3 over 2. And then you've got to multiply by the differential of this, which would be 4x. Why did I put 4x? 16x. Being daft there. So then if we multiply, put this all together, minus a half times 16x would be minus 8 times by 5 is minus 40x. 8x squared minus 1 to the minus 3 over 2. Right, obviously at one point you're going to have to start using this for something. So for example, an equation of a tangent. So if we find the equation of the tangent to y equals 2x minus 1 cubed at 327. That's question 6. So the first thing we're going to do, like you would do when you're working out any tangent, is differentiate it, because you need to do the differential to find out the gradient. So following the rules from before, multiply by the power, lower the power by 1, and then multiply by the differential of this, which is 2. So that gets you 6 2x minus 1 squared. Now we want to find out what the gradient is at a certain point at 327. So what we're going to have to do is plug x equals 3 into that function. So 6 lots of 2 lots of 3 take 1 squared. So 2 times 3 is 6, minus 1 is 5. Squared is 25 times 6 is 150. So that means we have a gradient of 150. So if we use y minus y1 equals mx minus x1, and we know that our gradient is 150, our x1 value is 3, and our y1 value is 27. Pop that into there. So y minus 27 equals 150 lots of x minus 3. Expand it. Add on your 27. And you got your answer. And since we've done the equation of the gradient, equation of the tangent, we might as well do the equation of the normal. So let's do, for question 7, find the equation of the normal to y equals 2x minus 1 to the 4 at 1, 1. So the first thing, like before, find out the gradient by differentiating this. Multiply by the power, lower the power by 1, multiply by the differential of that. So that would be 8, 2x minus 1 cubed. At 1, 1, that would equal 8 lots of 2, take 1, so 8 lots of 1 cubed, or just 8. So, only thing is at this point, because we're now talking about the normal, not the tangent, you have to go and do the negative reciprocal of that. So, our gradient is going to be negative 1/8. So, the normal gradient. then if we go back to doing y minus y1 equals mx minus x1, then if you pop in minus an eighth, x minus 1, y minus 1. Apologies, I didn't realise that was so low on camera. Hopefully that makes sense there. Then if we expand that, you get y minus 1 equals minus an eighth x add 1/8. Y equals minus an eighth x add 9/8. Or there's various other forms. So you could have, you could have 8y equals minus x add 9. Or you could have x add 8y minus 9 equals 0. Right, so what we're going to do now, or what I'm going to do now, is send out this with some questions. I'd like you to try these today because tomorrow I'll be sending through a video on the product rule, and then Friday Mr. Smith will be sending through one on the quotient rule, and each day we'll have a smaller exercise for you to practice that thing. Right, I'll see you on the next one.